everyone, and welcome to SoloCon 2021. My name is Idit, and I'm the founder and CEO of solo.io. And you're joining me here virtually in the headquarters of Solo at Cambridge, Massachusetts. I'm really looking forward for 3 engaging and instructive days ahead of us. When I started Solo over 3 years ago, there were 3 significant trends in the market. Enterprises were migrating their monolithic application to microservices architecture. They were interested in running those microservices on Kubernetes clusters, and they were adopting a multi-cloud strategy. Although those trends brought a lot of benefit to their adopter, they also introduced some new challenges, specifically challenges around connectivity. Connectivity on the edge, how do you expose your application to the outside world while still forcing security? Inter-app connectivity, how do you connect to application on your organization? And intra-app connectivity, how do you connect those microservices and compose your application? And of course, you wanted to run it on a multi-cloud environment, multi-cluster environment, or potentially multi-platform environment. At Solo, we were eager to solve the connectivity problem. In 2018, we announced Glue Edge, an API gateway based on top of Envoy that are run natively on Kubernetes. With Glue Edge, we were focusing on solving the connectivity on the edge, as well as the inter-app connectivity. At late 2018, we announced Glue Mesh. Glue Mesh is a management plane that helps you streamline your adoption and operation of STO service mesh for single cluster, multi-cluster, all the way to multi-cloud. With Glue Mesh, we're focusing on solving the intra-app connectivity problem. So at the end of 2018, we had the 2 building blocks that basically solve all the connectivity problem. But we didn't stop there. We learned from our customer how important it is to tune STO for your own special need. So in 2019, we announced Glue Extension. With Glue Extension, you can build, share, and deploy WebAssembly model on your STO service mesh to customize it and extend its functionality. Now that our customer has an advanced cloud native environment, it is important to educate their developer and help them consume available API. So in 2020, we announced Glue Portal, the only developer portal for STO. With Glue Portal, you can catalog and expose running API in STO for a developer, partner, and community member. Those are the components who are building the Solo connectivity platform. It has a Solo DNA to consume cutting-edge technology. So we build a platform on Envoy proxy, STO service mesh, WebAssembly, and of course, everything running natively on Kubernetes. And we were busy. On the last 2 years, we consistently deliver new feature and enhance the scalability of our platform. Efficiency and velocity are Solo key differentiator we believe in doing. At SoloCon alone, we are going to announce over 5 new announcements. So stay tuned. We couldn't have done it without partnering closely with our customers and our community member. Today, Solo helps thousands of users to run Glue and STO in production, from small startup to household name and Fortune 500 company. We have over 3,000 active members on our Slack open source community, and we really hope that you will join us too. A few of our customers were kind enough to let us use their logo, but actually, there is way more people who's using Solo technology in production today. Most likely, you are leveraging Solo technology by using your credit card, by talking on your phone, by checking your bank account, by going to your favorite restaurants. We really honor you are trusting us with your business. Some of our customer and community members will share their story at SoloCon. I encourage you to check it out. This is an exciting time for Solo. During the last year, we show quarter-to-quarter exponential growth in user, customers, and community members. We have a strong demand for a Glue Mesh product, and after a very successful beta, we are busy deploying it on our customer production environment. We are proud to be leader and an active member of the STO and Envoy community, and we are committed to continue contributing upstream. On the last 3 months, we over double our employee heads count and welcome strong leader of the cloud and open source community to our team. Based on the current demand, we'll have to double it again. And the first SoloCon. So thank you so much for being part of our journey and our growing community. Next, I want to introduce you our global field CTO, Christian Posta.
Thank you, Adit, for that overview of what we've been doing here at Solo. And now I'm going to take a look at some of the problems that we're solving, the approach that we take to solving them, and the products that we've built to facilitate that. My name is Christian Posta, and I'm the field CTO here at Solo. I've been here for over 2 years now, but I've been helping organizations build and scale distributed systems and microservice style architectures for quite some time now. I've written books on this topic, and I'm extremely excited that for the last 4 years I've been in the service mesh ecosystem, and that we've built a team here at Solo that lives and breathes these technologies and these solutions, and that we're working with our customers, and we see positive influence and positive impact from what these technologies are able to bring. And the context that we're looking at is organizations modernizing their application architectures, going to things like microservices, adopting infrastructure like containers and Kubernetes, and living in a world where there's still virtual machines, and some teams are doing functions as a service and so on. But once they've built the infrastructure and the engine to deploy these applications into a cloud service or a Kubernetes container system, these applications need to communicate with each other, and more so now, because now there's more of these services. And communicating over the network, as we've known for a while, is challenging, right? There's no safety guarantees, there's no security guarantees, there's no time guarantees. And when a service tries to communicate with another service, it needs to know where that service exists. If that service starts misbehaving, it needs to know how to do timeouts and circuit breaking and load shedding. And when you start to introduce new services into a system like this, you want to control the scope of what other services or users get impacted by it, right? You want to do things like canary releases or dark launches. And so the infrastructure to support this type of thing doesn't exist, or has been very ad hoc up until recently. And that has shown up in various surveys when you look at it closely, that show people are able to move faster and deliver code to production faster, but their safety metrics are not improving. In fact, they're going the opposite way. So things like change failure rates are increasing, things like mean time to recovery increases, and availability goes down. So what we're looking at here at Solo is, how do we solve the problem of service to service and application connectivity over the network in these cloud-based environments where applications are ephemeral, services could be scaling up or scaling down, and the previous generation of technology was not built to solve that problem and live in that context. So the things that we're doing here are focused on how can we improve the traffic control between applications. How can we improve our security posture, especially now where there are more pieces and they're highly distributed? And lastly, but probably most importantly, we need to understand what is actually happening between these applications. When we go to microservices, we've moved some of the complexity between the services, and we need to observe and understand what is happening, especially when things go wrong, so that we can correct it. The previous and past approaches, they were built for infrastructure that was more static, VMs, physical machines, and so on. And in some cases, they were built to support API externalization and consumption and so on. But what we actually saw was people start to use these systems to solve the traffic problem or the observability problem or the security problem, at least to some degree. So things like Apogee, things like Layer 7 or Data Power or Kong, any of these, they were all built in the same generation of technology for those underlying context or that underlying infrastructure. We see these things as being more centralized. And traffic, if service A tries to talk to service B, it's going to have to go up through this centralized system, which also means you need centralized processes to lock this thing down, to make changes to it, and that's exactly what we saw. Now, in a cloud-native, highly ephemeral, highly distributed environment, this type of approach does not lend itself well to solving some of these problems that we're talking about. So that brings us to technology that was purposely built and specifically built to live in this type of environment. And that is Envoy Proxy. Envoy was built specifically to bring observability to applications as they communicate with each other over the network, specifically to be able to control the traffic and improve their security posture. Envoy is an open source project that came out of Lyft as part of the CNCF, one of the first few top-level graduated projects, and is a very vibrant and diverse community, and is where the innovation in this cloud-native proxy space is happening. At Solo, we recognized this very early on, and we were building our solutions on top of Envoy from the beginning. So we take a look at the approach that we have here at Solo, and that is highly decentralized API infrastructure to solve those problems around traffic control, security, and observability. Now, we have products in the API gateway space, which is what we started with. Now we've branched out into the service mesh space, and we've been very focused on WebAssembly for the last year and a half, or actually longer, to be able to extend this type of infrastructure. And then connecting the applications, securing them is all good and well for infrastructure folks, but for developers who want to find and start using these APIs that live in this infrastructure, a developer portal that lives on top of this is extremely important. So let's take a look at what the products do and how they work. So we started, like I said, with an edge gateway. This is the simplest of the frameworks that we've built and that people can adopt and not have to boil the ocean to try to get working. It's a familiar part of the architecture. How do we get traffic into a system using something like an ingress gateway or API gateway? These are familiar concepts. Our gateway is a little bit different though. First of all, it's built on Envoy and has been from the very beginning. We've been running this in production in our organizations for 3 years. We deeply understand Envoy. Second, we've built it in such a way that it is intended to be deployed in a decentralized manner. So in this case, we're looking at it as a Kubernetes ingress. But if you start to deploy that across multiple clusters, right, you don't have any centralized bottlenecks or centralized gateways, and each of the clusters can live independently and federate with each other. We've also built it so that you can extend the capabilities of Envoy with WebAssembly. We actually have customers in production with WebAssembly right now, so this is not just some futures-looking thing, it's a now thing. And in general, it was built to be Kubernetes and cloud native, so there's no extra databases that you need to spin this up, no extra high availability for Cassandra and all this other junk that you need with some of the older technology. It's extremely easy to install and operate. It's intended to run across multiple clusters and be federated. Security is a big set of features that we focus on at the edge, because at the edge you need things like rate limiting and request transformation and proving the trust with some of these unknown users using things like OIDC or OPA or API keys and so on. And then lastly, it's built for both external and internal API use cases. And we see a lot of folks using it for that internal API use case where they've deployed across multiple clusters. And as traffic goes from one cluster to another, or maybe even crossing boundaries, that we're enforcing security policies and we're enforcing usage policies and collecting telemetry and tracing and all of this stuff just by using an edge gateway. Now you may have heard of things like service mesh and so on, but we're able to do a lot of this stuff just with the edge gateway. We've built a federation and automation plane to be able to manage this across multiple clusters and simplify the operational day two aspects of doing something like this. And this pattern can take itself to its logical conclusion, which is across different clusters, different lines of business, potentially even different clouds, you start to build sort of a mesh of edges where you have all of these different control points and enforcement points for different usage policies and security policies, access policies, these types of things. And you're not restricted to any particular type of infrastructure on which to run this. I've mentioned this is cloud native or Kubernetes native, but it can run outside of Kubernetes as well. Now, if you squint here, you start to see these edge gateways start to form a mesh between the various boundaries that we've outlined. And so let's take a step back and look at how that works with an actual service mesh. And so that's where Glue Mesh Enterprise starts to come into the picture. So Glue Mesh Enterprise is a service mesh. It's Istio, it's upstream Istio, and is supported for enterprise usage. We can go a little bit deeper, even across multiple clusters. We've built a management plane to federate Istio across multiple clusters. And again, across different boundaries with things like access policies, things like traffic control policies, federated trust boundaries, service discovery. And these are all extremely powerful features once you start to connect applications to each other. So we've seen the edge where traffic comes in, potentially untrusted, and now we're looking at traffic in the east-west direction where services are communicating and talking with each other, and scaled out across multiple clusters, multiple clouds, potentially even multiple versions, different versions of Istio, different versions of Kubernetes. So maybe in the past you were worried about how are you going to federate your Kubernetes clusters. This is it, through the network. And we've built the management capabilities, the automation capabilities, just to support you and make you successful with this. So Glue Mesh is enterprise supported Istio with upstream long-term support and -3, so they'll last about a year worth of a particular release of Istio, with security patches and backporting and so on, with FIPS compliant builds for those running on FedRAMP and DoD type workloads. And like I said, we manage this across multiple clusters. We reduce the configuration toil that you have to worry about. Istio's APIs can be kind of verbose and low level. We've built a simplified API to abstract away those pieces that is multi-cluster aware. That is, insofar that it's multi-cluster aware, we're able to do telemetry gathering and log aggregation and start to build dashboards, graph-based dashboards on top of the applications that are running across these multiple clusters. So you can see exactly where things are going wrong when they do, what cluster they're having issues, and so on. And lastly, again, we take security very seriously here at Solo, both at the edge and between our applications with the service mesh. So we're able to get mutual TLS and identity verification end-to-end between the services, even if they're bouncing from cluster to cluster. So bringing this together, what we see here is we're able to secure traffic, to control traffic and observe traffic coming from unknown and untrusted areas into our system and between our applications, regardless of the infrastructure, whether that's Kubernetes or VMs or cloud. Right? And we are able to give a single pane of glass to simplify operations of an architecture like this and enable your application developers to focus on the parts that they need to focus on, which is building the services, not where do these services live, how do I do timeouts, retries, circuit breaking consistently across languages and frameworks and so on. What we've built here and what you can leverage is a smart network that's able to do routing, it's able to do security, able to elicit these golden metrics from the network to make your system smarter and understand how to reason about it when things start to go wrong. The last piece is developers care about APIs and they care about accessing them. And we want to reduce the friction to accessing them, even in a highly distributed network like this. And so that's where we've built Glue Portal. Glue Portal is a cloud-native, multi-cluster approach to getting access to APIs that might live somewhere in your network, and putting into place the automation so that when you enable access to an API, that automates the configuration for any edge components or any service mesh components that might be in the path of getting access to that API. So our developer portal offers self-service, so the developers can go search for, sign up for, and start consuming APIs for operators to put usage plans around these APIs, to secure them and do that again, like I said, in a highly federated approach. Now, stay tuned for day 2 tomorrow, where we will announce more things around the developer portal. So, a modern application platform that facilitates bringing new changes to the system in, new deployments, reduced lead time, all that is good, but you can't have that without also balancing the safety aspects around reducing change failures, or at least limiting the change failure rates or the blast radius of those changes, reducing the mean time to recovery. If things start to go wrong, and they will, can you quickly identify where and remediate them or fix them in a timely fashion, as well as availability. You don't want cascading failures. You want to be able to route around failures. You want to be able to be dynamic in the routing depending on what's happening in the system at any particular time. And that's where the solutions that we've built to help you focus on successfully deploying and operating things like a service mesh, for securing traffic at the edge, and then extending those using WebAssembly where it makes sense to be backward compatible with some of your existing workloads that might be running in VMs or running somewhere that require different security hooks and telemetry extensions and so on. And then lastly, being able to find these services and see their documentation and test them and self-service sign up for them. The developer portal is a very important piece to this puzzle. So the way we see our customers successfully adopting this technology and these architectures starts with the crawl, walk, run principles of adopt something that you're comfortable with, that is small enough, that delivers enough value to justify doing it, and then iteratively introduce other parts. So usually what we see is people start with a gateway, whether that's Istio Ingress Gateway, or they need something more powerful at the edge, like a Glue Edge Gateway. And then we start to see them build processes around this, GitOps and so on. Everything that we're doing here at Solo is based on declarative configurations, so it fits very nicely with a GitOps workflow. And then slowly start to introduce things like the East-West service mesh, like Istio. And you don't want to do that alone. We have the expertise here at Solo to help you successfully do that and get enterprise support for Istio. And once you've gotten Istio into place and you've solved some of the edge gateway problems, now you're going to start to spill out into more clusters, more lines of business. You're going to have more extensions that you want to bring to the system. You want to start to build approval workflows and how teams work with each other. And then lastly, you start to get to multi-cluster and multi-cloud and running these things at scale. And what we've done with Glue Mesh and the automation around Glue Mesh to simplify that operation story is where we start to really fly. That's where we start to get the benefits of our APIs, being able to move quickly, of simplifying the developer's life and the operator's life for doing this, and is where I am especially excited to see and announce what we're doing next. And for that, I'm going to hand off to Joe, Joe Kelly, who's the manager and leads the Glue Mesh team at Solo. So Joe, this is all yours. Continue the story from here.
Thanks, Christian. Hi, everyone. I'm Joe Kelly, the engineering lead on Glue Mesh at solo.io. Glue Mesh is a management plane for service meshes that provides a single pane of glass for managing meshes across compute environments and mesh implementations. When you register a Kubernetes cluster to Glue Mesh, it automatically discovers all your meshes and mesh-injected services. From there, you can define a virtual mesh to expose your services to one another however you see fit. Members of the virtual mesh are configured under a common root of trust, enabling secure communication over MTLS across clusters and traditional service mesh boundaries. This empowers you to reason about your distributed services as logical sources and destinations for network traffic, regardless of where they're physically running. Glue Mesh users can leverage our source and destination semantics to author explicit access policies to specify which workloads can access which services across all clusters in your environment. This helps ensure that your security posture remains intact as the footprint of the mesh expands. The same source and destination semantics can be used to apply traffic policies, such as retries, timeouts, fault injection, and more, to the various edges of your service graph. Glue mesh traffic policies can be applied globally or at the service level, allowing you to harden, test, or otherwise configure your network's behavior in as fine or as coarse of a manner as needed. Access to all Glue Mesh APIs is granted via our expressive role-based API. Administrators can define personas with specific permissions to configure individual or classes of services and policies at many levels, all the way from global access to any policy to restricted permissions to adjust just a single knob on a single service. This goes a step beyond traditional Kubernetes RBAC and puts guardrails in place to ensure that each user can only affect traffic that they have been explicitly allowed to configure as mesh administrators, service developers, or whatever other role makes sense in the context of your organization. This is only the beginning of the functionality that Glue Mesh brings to Service Mesh and beyond. There's plenty more to cover about how Glue Mesh enables you to observe your services and extend the functionality of Service Mesh. For that, I'd like to welcome some additional team members to share what they've been working on. First, let's go to Scott to describe the architecture of Glue Mesh and how it securely manages multi-cluster mesh configuration.
Thank you for that, Joe. So, hi everybody, I'm Scott Weiss, architect at solo.io, and I'm going to talk about how we do multi-cluster I/O in Kubernetes. So, what do I mean by multi-cluster I/O? Essentially, when you have a scenario where you're managing multiple clusters, any kind of configuration and any kind of interaction with an API server from a centralized location, you need a way to essentially to do the I/O, to insert objects into etcd and read them back out. So this is already implemented in several projects today, and they all take essentially the same approach. What they do is they take the data plane cluster and they register it, which means that they create a service account on that cluster. Kubernetes provides a service account token that corresponds to the service account and the RBAC that's associated with it. Then what we do is we take that and convert that to a Kubernetes REST configuration and then supply that to the control plane cluster, where the controller is running that manages the data plane cluster. This is implemented today in Istio. It's how Istio does its multi-cluster watches for endpoints. It's done by Admiral, which is a tool by Intuit, which allows you to fail requests over from one cluster to another. It's done by kubefed, which is more of a generic project by the Kubernetes community to enable configuring multiple clusters from a single location. It is also what is being done today by Glue Mesh in our pre-1.0 versions. But there are some drawbacks to this approach. So one is it provides no way to bound the scale of clients that are talking to the remote API server. You can, in a high availability scenario where you have multiple control plane clusters, will wind up with multiple watches on these remote data planes, which can quickly get out of scale, especially if you're watching something like pods or endpoints. This is also provides a huge security problem. This is something that we were told by our customers, some of our customers would be completely unacceptable, which is the idea of taking a secure Kubernetes credential and taking it outside of the cluster where it was created and shipping it into another cluster. Basically, we want to not ship those credentials across secure boundaries. And the last piece, which is particularly painful for a number of users, is that you cannot use this cluster registration flow via Helm, because it requires that we first create a service account in the data plane cluster, wait for Kubernetes to provision a token, and then extract that token out, which Helm provides no mechanism of doing that today, which means we cannot independently register the control plane cluster and the data plane cluster, or we cannot independently set them up. So looking at all of these drawbacks and limitations, we've decided to go with a new approach that's going to be rolled out in our 1.0 GA release of Glue Mesh. And this is something we call Relay. And the way it works is it utilizes an agent server architecture to establish communication between two Go processes that live in each cluster, in the data plane and control plane clusters. The way it works is that the relay agent starts up and it establishes a bidirectional gRPC stream with the relay server that lives in the control plane cluster. This all goes through a secure ingress. Once this connection is established, the relay server then instructs the relay agent what resources to watch and fetch from its local API server, as well as what it needs to write to that API server. That way, only the relay agent is ever directly responsible for interacting with its local API server, and we are able to come with an API. The gRPC stream allows us to control specifically what features, what resources we're allowed to watch and read from a remote cluster without exposing the whole Kubernetes API server. So let's discuss some of the advantages of this model. One is that Kubernetes credentials never leave the cluster. We now don't have to distribute access directly to any API server to something outside of the cluster. Additionally, the agent can also filter out any unnecessary data. Let's say you're watching the whole set of pods, but you only need to know about the pods that changed. We can now send deltas, which are just the individual resources that changed or even subfields of those, across this gRPC stream without needing to utilize the entire Kubernetes Watch API. So we also have better support for scaling in HA because we can now scale up the number of control plane clusters without needing to scale the number of watches on the remote API server. And finally, this is really nice because it's an entirely helmable setup. Rather than needing to create a service account token that we then extract into a remote cluster, we can simply provide a shared secret to establish the trust between the agent and the server independently, and they can bootstrap the entire configuration flow in a declarative model rather than needing to be imperative. I would like to go into and spend a little bit of time talking about the handshake that happens in order to establish identity. We're happy to take questions in the chat in order to explain this in further detail, but I don't want to take up too much time. Just let it be said that the server acts as a certificate authority and signs client certificates on behalf of the agent so that we can then trust and verify that the agent is actually the identity it says it is. I'm going to pass it back to Joe. Thank you so much for your time, and we're really excited to share more about our architecture and designs.
Thank you, Scott. Next, let's go to Harvey to talk about observability in GlueMesh.
Hey, Joe. Thanks for the introduction. So GlueMesh comes packaged with a set of observability features that allow the user to get painlessly up and running with a complete observability suite. And I can go over the architecture of that briefly right now. As we see in this diagram, the top three boxes, they represent managed clusters. Each of them has a set of Envoy proxies as well as the GlueMesh agent. The bottom box represents the management cluster, where we've installed a management plane represented by the GlueMesh server. So GlueMesh leverages Istio to configure the fleet of Envoy proxies to treat the GlueMesh agent as a sink for metrics and access logs. This means that anytime an Envoy proxy emits a metric or an access log, it'll get sent to the GlueMesh agent, which in turn forwards them to the GlueMesh server. This process basically aggregates all of the observability data into a single place. From there, the GlueMesh UI as well as meshctl can plug into the centralized data source and present the data back to the user in a coherent and easy to navigate way.
These metrics aggregation features are a powerful way to bootstrap multi-cluster observability. But what about those organizations that already have a sophisticated metrics backend, like Prometheus, federated via Thanos?
That's a great question. So there are two parts to this problem. One is aggregating the metrics to a single place so that we can allow for system-wide multi-cluster queries. And the other is taking this aggregated data source and wiring it up to a user interface. GlueMesh will expose integration points for both of these problems. So if a user already has a sophisticated Thanos federation setup and they want to use that, they can just plug that in as the aggregated data source and then leverage GlueMesh for its UI. Alternatively, if a user already has a UI that they're comfortable with, like Datadog or Grafana, they could treat GlueMesh as a source of truth for aggregated metrics and plug that right into their UI. Here's a sneak preview of the GlueMesh observability UI that we will be showcasing in the demo portion of the observability talk. As you can see, something appears to be wrong with the connection between the product page and the review service. We will dig into this in the demo. I hope everyone can make it. Thank you.
Thanks, Harvey. If you're interested in hearing more about the nitty-gritty details of how GlueMesh collects and presents telemetry data, check out Scott and Harvey's session on observability in Istio. Next, let's hear from Eitan how Glue Mesh can make your environment resilient to regional outages and service downtime.
Thanks, Joe. I'm really excited to talk to you all about how you can use Glue Mesh to configure highly available services which are resilient to regional outages and service downtime. And the way we're going to do that is with our virtual destination API. But before we talk about specifics of this said API, let's quickly talk about the scenario that we're looking to tackle. And no better way to do that than with a diagram. So, in our quick demo scenario, let's say we have 2 clusters, each of which are running in a different region. Now, this is already good practice, because if something were to go wrong in region 1 or region 2 with the entire cluster, there is a backup available. However, what if something were to go wrong with, let's say, a user service in cluster 1? Well, with this new virtual destination API, Istio will seamlessly route traffic to the user service running in cluster 2 or region 2. Similarly, if the user service were to go down in cluster 2, it would seamlessly route traffic over to the user service in cluster 1, region 1. Now, as I alluded to earlier, this can already be done in Istio. But let's discuss just what you would need to get that done. Well, you would need 2 virtual services, 1 per cluster. You would need 3 destination rules, at least 1 per cluster. You would need 1 service entry, 1 gateway, and 1 envoy filter. So just right off the bat, that's already 8 CRDs. And that's just for this single service. And that's not counting all of the configuration required just to get multi-cluster Istio working, which Glue Mesh handles for you automatically. So now let's talk about how this would work in Glue Mesh. Well, it would require 1 virtual destination and 1 traffic policy. That's 2 CRDs compared with 8. So now that we've talked about just how simple using the virtual destination API can be in comparison to the Istio API, let's actually take a look at an example of how to use it and what it would look like to accomplish the failover that we mentioned in the previous slide, specifically with the globally available user service. So as you can see here, there's a pretty typical looking Kubernetes API. So let's step through it piece by piece. First, we have the host name. This is the DNS address at which this service or virtual destination will be available to the entire mesh or any of the meshes in your virtual mesh. Next is the port. This is the port that this will be available on. Next is outlier detection. This is how we tell Istio or Envoy when a given service is unhealthy. The one shown here is definitely not production ready, as it will fail after 1 error, but it is just for example purposes. And next, probably most importantly, is the selector. And this is how to tell Glue Mesh which services will be a part of our virtual destination and which services should be failed over to in case of any failure in the services. And lastly is our virtual mesh. And that is the virtual mesh which to expose this virtual destination. The magic of this API is that it allows you to group a bunch of services across different clusters, localities, and anywhere around the world into one logical group such that it will route to the most proximal service at any given time. And if any of those services were to go down, it will immediately route to the next available option with this 1 CRD. Thanks, Joe. Back to you.
Now, let's check in with Yuval, who's here to tell us about how Glue Mesh can help you leverage WebAssembly to extend your service mesh's data plane.
Thanks, Joe. We believe that WebAssembly opens up quite a few use cases for service mesh customization in enterprises. With WebAssembly, you can dynamically and safely inject custom behavior to the network traffic as it traverses the mesh's data plane. Our goal with Glue Mesh is to fully enable WebAssembly usage and provide a Docker-like experience for service mesh extension development. With Glue Mesh, we handle the WASM experience from end to end, from developer bootstrapping the code, building the WASM filter, binary distribution to a registry, and finally, deployment to your service mesh workload sidecar. We have built a developer workflow into our meshctl command. Meshctl, the glue mesh command line, can help you get started with WebAssembly. With meshctl, you can initialize a new filter from various templates for different programming languages, build the filter code into an OCI WASM image, push the OCI image to a Docker-like registry, and deploy the image from the registry to a specific load code in your service mesh. Back to you, Joe.
Thanks, Yuval. It looks like Glue Mesh goes a long way to making the developer experience for adding WebAssembly extensions to Envoy proxies really easy. But what are some of the use cases our customers have had for WASM extensions to Envoy?
That's a great question, Joe. As WebAssembly in the mesh data plane is a recent innovation, we have been lending our expertise and helping our customers to get the most out of it. Let me share some use cases we have seen as examples on how WebAssembly is used to customize the service mesh to specific business needs. Things like custom authorization schemes. Up until now, to implement custom authorization, you would have to use a mechanism called external auth. This entails creating and maintaining an authorization server and involves a network call from the data plane to the authorization server to make authorization decision for each and every request. This introduces latency and reliability concerns. In many auth schemes, like HMAC signature verification for example, WebAssembly used to avoid the extra network call and perform authorization directly in the data plane. The next example, custom routing based on request properties. For example, modifying the headers based on a specific value in the body of a request. Another example is custom metrics or access log. For example, logging the message type in a custom RPC protocol. And the last thing I'll mention is custom request transformation. This is commonly used to support legacy backends. These are all examples on how WebAssembly together with Glue Mesh can help you get the most value out of your service mesh safely. We at Solo are excited to unlock the opportunities of WebAssembly together with the community and can't wait to see what we can do together. Back to you, Joe.
Thanks, Yuval. Looking forward to going deeper on this subject at your session on extending Istio and Glue Mesh with WebAssembly later today. That's all on Glue Mesh for now. To hear more about our vision for the product as well as upcoming features, tune into the Glue Mesh Roadmap session with me and Christian. With that, I'll send it back to Adit to wrap up.
Thanks so much, Joe. It's very impressive the work that you and the team are doing. And thank you for joining the first SoloCon keynote. We have a great talks lined up for you today. I really hope you can stay. Before I'm letting you go, there is one more thing. The motivation behind building Glue Mesh was to make STO so easy and consumable that it just works. We keep asking ourselves, can we make it even simpler? And we think we can, with cloud delivery model. With the movement to the cloud, our customers enjoy from an experience of consuming their services as a managed service. And they requested from us to make Glue Mesh and STO available as a managed service. Today, I'm so excited to announce Glue Cloud, the first and only fully managed STO service mesh for any cloud. With Glue Cloud, you can enjoy the powerful feature of STO and the extensive feature of Glue Mesh without need to manage it yourself. We are very excited to have you try it and looking forward to get your constructive feedback. If you want to learn more about it, I encourage you to check out the session of Glue Mesh Roadmap by Christian Posta and Joe Kelly tomorrow. Thanks so much for joining us at SoloCon. Next, we will have Christian Posta live session, How to Select the Service Mesh. I really hope you can join. I'm hoping to see you all in person on the next SoloCon 2022. For the meantime, stay positive and test negative.